Today we're going to look at the second part of chapter 9.5. Last class we introduced the topic, but I wanted to go into more detail today. Last time we talked about Pascal's triangle and what that looked like, and we just introduced binomial expansions, but we're going to go into more detail today. So reviewing Pascal's triangle starts with the 1 on top, then 1 and 1, and then adding each of the elements together to get the next element. So 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 4 plus 6 is 10, and so on down the line. And this could go on infinitely if we wanted to. We looked at how to represent different elements of Pascal's triangle. Remember, it starts with row 0. So the fifth row would, from the previous slide, would be 0, 1, 2, 3, 4, 5, 1, 5, 10, 10, 5, 1. And then we looked at how to generate the sixth row and what that would look like and what those element numbers would look like. So we're going to be using that information today, so make sure that you keep that handy, and also the different ways to represent it. Remember that it starts with the 0th element and 1, 2, 3, 4, 5, 6. So the sixth row has 7 elements in it, starting with element 0. All right, then we looked at the in-class practice, and if you need to go review that, you can do that. The solutions are on the class webpage. All right, then we talked about the binomial theorem. For any x plus y to the nth power, we can expand it this way, where the coefficient of x to the n minus r, y to the r, is this nth row rth element of Pascal's triangle. So n factorial divided by n minus r factorial times r factorial. That's a mathematical way of representing this, but the easy way to do it is just to grab it from Pascal's triangle. And again, we can use this notation and this notation. They're just the same thing. So we looked at an example of expanding x plus y. So x plus y to the nth. So x plus y to the 0th power is just 1. X plus y to the first power is x plus y. And then we looked at squared, cubed to the 4th, to the 5th. And you'll notice that the coefficients are Pascal's triangle. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. And the x terms go in descending order of exponents. So here I've got x to the 5th, x to the 4th, x cubed, x squared. And the y terms go in ascending order of exponents. So y to the 0th is just 1, then y to the 1st, y squared, y cubed, y to the 4th, y to the 5th. And you'll notice that each expansion adds another term to it. And we looked at how x to the x plus y to the 10th will have 11 terms, and so on and so forth. So we're going to keep this information handy, and then make sure that we understand how to apply Pascal's triangle as coefficients to that. So here's an example. I've got 2x plus y, 3y to the 4th power. Now on the previous slide, I'm going to substitute 2x for x on the previous slide. I'm going to substitute 3y for y on the previous slide. And I'm going to combine all these terms together to get my binomial expansion. So let's look at the x term first. Again, it's 2x, and the x terms go in descending order of exponents. So it's 2x to the 4th, 2x cubed squared to the 1st to the 0th power. The second term, the y term, goes in ascending order. So it's 3y to the 0th, which is just 1, 3y to the 1st, 2nd, 3rd, and 4th. Then we have to apply Pascal's triangle, the number from Pascal's triangle, as the coefficient. 1, 4, 6, 4, 1. That's going to be the 4th row. Then I multiply these all together to get my final binomial expansion. So here I'm going to have 2 to the fourth is 16, x to the fourth. This is just 1. This is 1. So my first term is 16x to the fourth plus my second term. If I multiply these all together is 96x cubed y plus the next term plus the next term plus the next term. Now you can multiply these all together to make sure you get those answers, but I think you'll see how we get that. So let me give you a minute or two to look at that. And if you need to screenshot this or if you need to come back, you can look at that. All right, just a couple practice things. Let's calculate the 8th row, 6th element from Pascal's triangle. I could just look at Pascal's triangle, but if I didn't have the 8th row, I could calculate it this way. 8 factorial divided by 2 factorial divided by 6 factorial is equal to 28. Now, factorial is on your calculator under the math functions. So make sure you know how to do that. All right, now use binomial theorem to expand and simplify this expression, a minus 6 to the fourth. Well, here my x term is a, my y term is negative 6. So my a's go in descending order. My negative 6 goes in ascending order, so negative 6 to the 0, negative 6 squared, cubed to the fourth. And then I need to multiply that by Pascal's triangle number. So 1, 4, 6, 4, 1. If I multiply that all together, this is the result that I get. All right, let's continue on. So I use binomial expansion to simplify this expression. Here I've got x squared plus y squared to the fourth. I'm going to substitute x squared for x. I'm going to substitute y squared for y. So my x goes in descending order. But again, I'm substituting x squared for x. So we have x squared to the fourth, x squared cubed, x squared squared, x squared, and x squared to the 0th power just is 1. My y squared is going in ascending order. So y squared to the 0th is just 1. Y squared squared, y squared to the cube, then y squared to the fourth. Now remember from algebra 2 that if we take a value, an exponent, and raise it to another exponent, we multiply the exponents together. So it's going to be x to the 8th, and 4x to the 6th plus y squared, and so on down the line. So the trick here, make sure you multiply by Pascal's number, do your x's in descending order and your y's in ascending order. All right, let's take a look at this one. It says find the specified nth term in the expansion of the binomial. So it's going to be since it's raised to the 9th power, it's going to be the 9th row. And the ninth element is actually going to be element 8. Remember, we start with 0. So we're going to find 9th row element 8. 9 factorial divided by 8 factorial times 1 factorial. Is your Pascal's number for that is 9. But now what do we have? It's the element 8 in that row is going to be your x term is just going to be x to 4x to the first power. Your 8th element is going to be 3y to the 8th power. And multiplying it all together, we come up with this large number. So here, the x term, since remember the x is going descending order, it goes from 9, 8, 7, 6, 5, 4, 3, 2, 1 for the 8th term. And here it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, okay, for the y term. All right, find the coefficient A of this term in the binomial expansion, x minus 2y to the 9th power. So we're going to find ax to the 4th, y to the 5th. Well, this is going to be the 9th row, because again, the exponent is 9, and we're going to find the 4th element. So it's going to go, again, the element 4 is going to be 9, 8, 7, 6, 5, 4, and for y, 0, 1, 2, 3, 4, 5. So figuring Pascal's number, we can do it this way, or could have looked if we have a big enough Pascal's triangle. 126. My x term is just x, so it's x to the 4th. My y term here is negative 2y, so it's negative 2y to the 5th power. If I multiply that all together, I get this result. All right, this difference quotient, this is something that you're going to look at if you ever get into calculus. But this is just another application of the binomial theorem. So here I have f x plus h minus f of x all divided by h. My function is 3x cubed. Well, what do I have? I have 3x plus h cubed minus 3x cubed divided by h. Well, if I expand this out, I've got 3x cubed plus 3x squared h plus 3x h squared plus h cubed. So there's our binomial expansion for something to the 3rd power minus 3x cubed. So the 3x's cancel out. If I multiply, I'm sorry, 3x cubes cancel out. If I multiply through by 3 here, I've got 9x squared h, so the h's cancel out there. Here the h squared and h, one of the h's cancel out, and here one of the h's cancel out. So I can reduce it to that. So again, this is something you're going to look at in calculus more next year, but this is just an application of binomial expansion here. All right. The last thing we're going to look at today is complex numbers. Now, these get a little bit tricky with the positives and negatives, so we really got to keep that straight. But let's look. We got 7 minus I to the 4th power. My x term is 7. My y term is negative I. So plugging it into my binomial expansion, again, these go in descending order. 7 to the 4th, 7 cubed, 7 squared, 7. 7 to the 0th power is just 1. My negative i's go in ascending order. Negative I to the 0th is just 1. Negative I to the 1st, negative I squared, negative I cubed, negative I to the 4th. So this is easy enough to multiply the real terms, but what about the imaginary terms here? So here I've got negative I, so that becomes a negative 1372I. Here I've got negative I squared. Remember, I squared is negative 1. Negative I squared is also negative 1. It doesn't matter if it's positive or negative, you square it, it becomes negative 1. So I've got 294 times negative 1. Here I've got negative I cubed. Well, negative I times negative I is negative 1. Negative I, so I've got negative I cubed, that's negative I times negative I, which is negative 1, times 1 more negative I. So there's your 3 negative i's, and it just becomes negative, so that turns out to be a positive. And negative I to the 4th becomes negative 1 times negative 1 becomes a positive 1. So now if I combine like terms here, 2,401 minus 294 plus 1 equals 2108. My imaginary terms, negative 1372i plus 28i gives me negative 1344i. And there is your complex number in standard form. You can also probably do these on your calculator, which would be the easy way to do it. But for the in-class worksheet, we will take a look at it, how to do it this way. So let's jump over to the in-class worksheet here, and I've got it right here. All right, so let's do these binomial expansions. 2x minus 4 to the fourth. My x term is 2x. My y term is negative 4. And so I'm going to do it this way. I'm going to do the x terms first, 2x to the fourth, 2x cubed, going in descending order. I'm going to take my y terms and go in ascending order. So negative 4 to the 0th power is just 1, negative 4, negative 4 squared, negative 4 cubed, negative 4 to the fourth, and then multiply by Pascal's number, 1, 4, 6, 4, 1. Now multiply this all together. I got 16x that should be to the fourth power. That's a mistake there. 16x to the fourth. Here, if I multiply these all together, it's minus 128x cubed. Multiply these all together, I get plus 384x squared. Multiply these all together, and negative 32x. Multiply these all together, I get plus 256. All right, let's look at number 6 here. This is a little tricky because we got a 3y plus 2. So I'm really substituting 3y for x, and I'm substituting 2 for y. So I've got 3y cubed plus 3y squared plus 3y plus 1. My 2's go in ascending order, so 2 to the 0th is 1, plus 2 to the first, plus 2 squared, plus 2 to the third. My Pascal's number for row 3 is 1331. So multiplying these all together, I get 27y cubed plus 54y squared plus 36y plus 8. And then finally, let's take a look at, I'll give you a second to jot that down. And then finally, we're going to look at one with a imaginary number. So I've got 2 minus I to the 5th power. So my x term is 2, so it goes in descending order, 2 to the 5th, all the way down to 2 to the 0th, which is just 1. My y term is negative I. So negative I to the 0th is just 1. Negative I to the first, negative I squared, negative I cubed, negative I to the fourth, negative I to the 5th. Well, let's look at what that is. I rewrote that as 1. Negative I is just negative I. Negative I squared is negative 1. Negative I cubed is negative 1 times negative I is plus I. Negative I to the fourth is negative 1 times negative 1 is a positive 1. And to the fifth would be negative positive 1 times negative I. It just gives me negative I. Multiply then by Pascal's number for that row, 1, 5, 10, 10, 5, 1. Multiply these all together. I've got 32 minus 80i minus 80 plus 40i minus 10 minus I. If I add those all up, combine like terms, negative 38 minus 41i. And that is a complex number in standard form. Again, the easy way to do this is you can do it on your calculator, but I want you to know how to do it this way as well. All right, and I think that is all we are going to do for today. So, and we could make sure we got those right answers. All right, so go ahead and get started on the 9.5 WebAssign and make sure you get that turned in on time. If you have any questions, make sure you let me know. And also your in-class worksheet, I want that turned in as well. So make sure you get that all turned in. Remember to turn that in with your Google Drive and share the folder with me. That's the easiest way for me to find it. So there are also examples in the book if you need more help. So make sure that you look at those examples as well. So that's all we're going to do. All right, thanks.